You're given a task to cast 4 upstand beams per building for 13 buildings. This is the plan. So I'll take you through the process, how we are doing it, then probably the materials and the costing of it. So this is what the building looks like. This is the front view of the building. Now you can see this red area that I labeled here. This is the upstand beam. Okay, upstand beams, they are beams that protrude upward, and the people, they use them in bathrooms and they also use them on balconies. Now the purpose of this upstand beam is to hold the glass. If you look at the second floor here, you can see that the glass is directly on this cantilever, right? It's directly on cantilever. So we are not doing that. Okay, so there'll probably be an update to the 3D. We're going to cast a beam here. Okay, then we're going to slide the glass into the beam. So that's what we're doing. So what you see here now is the floor plan. Is the floor plan of the first floor. You can see here. Okay, so this particular balcony that you see here, that we're going to cast the upstand beam for, that's the first floor, is what you have here. Okay, this one now is second floor, right? Let's go to the second floor. This is it right here. Second floor. Okay, now if you look at the building from the rear side, this is the back of the building, this is the side of the building, this is the front of the building. Okay, so if you look at the building from the back, you can see also there are 2 balconies on the first floor and the second floor. So that's 4 balconies. So that's 4 upstand beams per home, right? 4 upstand beams per home. So that's what is here, and that's what is here. Okay, usually in construction, when you are given a task, you don't build it from your mind. Everything requires calculation. Everything is calculated. Everything requires accuracy. Everything requires calculation. Everything requires accuracy. So we're giving this structure, the diagram, for that will guide us in casting our beam. Okay, so you know, of course, a beam is a part of construction equal reinforced concrete work. So that means that iron is going to be involved, wood is going to be involved, and concrete is going to be involved. And this is the plan for the upstand beam. You can see it here, the details of the upstand beam. Okay, so this, what you see right here, is the floor level. Okay, this is the floor level. What you see here is the height of the cantilever, the height of the upstand beam. So let's try and understand this diagram before we go to our steps of making it. Now, when you're doing a first concrete work, the first thing that you have to look at is the iron. Okay, and the iron has a specification. Right here now you can see that this iron specification is T10. Okay, and the iron are about 3. There's this one, this straight iron that goes here. There's another iron here. There's another iron here. So this is the side view of the iron. So if I'm looking at this thing, right, from the front, what I have is a couple of irons. What I have is a couple of irons. Okay, a couple of irons this way, and I'll have those 2 bars. They call these bars, the bars that are going this way, distribution bars, and these irons are called dowels, and they all have their purposes. You can see it looks like a net. Okay, so these bars are dowels. That's this straight one. This one that looks like a dot here that you can see is called the redistribution bar. Now the purpose of the dowel, before we start this casting, okay, you know, when you put your upstand beam, you want your beam to be firmly attached to the floor, and you don't want it to easily fall. So the first step is drilling. We have to drill. So you can see from here, they are saying that drill depth is 75 millimeter. So we have a drill, of course, a drilling machine. We use that to measure, you know, how deep we're going to drill, and that's about 75. Now, once we drill 75, our job is to place this T10 steel bar, okay, into the drill hole. And part of what we did was that not only did we place it into the drill hole, we filled this hole here with cement. And cement, when it comes to building, cement is a bonding agent, all right? So at least it just helps the steel bar, the T10, you know, holds it firmly into the hole. Okay, so the first thing we do is what? 75 mm drill depths. We put cement and put our steel bars. Don't forget also, our steel bars are 120 mm aside. They're about 120 centimeter apart from each other. Okay, so enough for us to do this now. Let's even look at, let's say we are casting for the first floor, and we are casting for, we don't have the distance. Let's say we are casting for this exact part here. Okay, and they said our steel bars are supposed to be what? At least 120 centimeters apart from each other. Of course, you won't place it too close to the wall. You probably place a steel bar here when you are drilling, right? So you place a steel bar here. You place a steel bar here. So I'm saying you place a steel bar here. You can place another steel bar. Of course, you have to count. You have to measure 120 centimeter. Place another steel bar there. Okay, you place another steel bar there. You place another steel bar there. That they call them dual bars, right? Place another one. You place another one. You know, you just keep on measuring 120. Okay, distances away from each other. You place them. They are vertical. Now, the thing is, okay. Now the thing is, Although it is said that you should place your steel bars 120 centimeter away from each other, they need to be at least, they need to not pass 120. You can place that 110 if you want. You can place it, but you shouldn't exceed 120. Now the thing is, if you are putting that something like 50, with 50 work, the distance from each other, yes. But if you're putting at 50, you're going to use more steel bars, and that's going to cost more for you in terms of material. So in construction, there's usually, you have to look at the requirement and how much it will cost, right? And look at the flexibility in between. So we look at that aspect, right? So we look at the bars, the doors. Now we also have to look at the distribution bars that we're talking about, right? The purpose of this distribution bar. So I want you to understand something. Concrete, just see it as a rule. If you are putting concrete, anything, if you are concreting anything, and the length is more than 4 inches, if you don't put iron in it, it's going to crack. If this door's job is to attach the concrete, to hold the beam to the slab, to the cantilever, to the floor, the job of these bars here, okay, is to ensure that when concrete dries, it shrinks, and if it shrinks, concrete cracks. Okay, so the distribution bars, they prevent concrete from cracking, and these distribution bars are tied at the nuts. They are tied at these points by something called binding wire. Okay, binding wire is used to tie them at these points. Binding wire. Binding wire. So now that we've looked at how the iron is going to be done, because iron is the first work, the next work that's going to be done is form work. You need a carpenter, and form work usually gives form to concrete. Okay, you need a very good form work because the concrete takes the shape of the form work. Just like when you put water in a cup, according to Bruce Lee, you put water in a cup, it becomes a cup. You put water in a teacup, it becomes a teacup. So the concrete is going to take the shape because it's like the body, it's like the container for the form work is the wood that is holding it, container for the concrete, right? So what we're going to use now for our form work, you have to use flat woods. The flat, we're using wheel wood. Okay, we're using flat wood. So we'll call the carpenter to come and do the form work. He's going to brace it. So usually the form work looks like this, right? So it's going to take the shape of that concrete. Remember, this is the floor here. This is the floor. This will take the shape of that concrete. If we're looking at the form work from the front, it's going to be flat like this. Of course, there's going to be a corner based on the shape of the balcony. Okay, then you have another form work here. I will go this way. This is the form work behind it, right? So you have form work in front, you have form work behind, and in between this form work is where we're going to be pouring our concrete. In between the form work, the carpenter will make, we're going to pour our concrete in between it. Of course, the carpenter is going to brace the form work this way, because when you fill concrete has load and they tend to push the boards apart from each other. So another wood will go, they are going to nail the wood here, and they'll nail it here and they'll nail it here, so they can hold the board at the top together. Okay, so they don't spread open. So it's going to brace it, and on and on. So when it does it, we're going to pour the concrete. Remember, it has iron in it, right? This iron that we have here is actually inside. The form work is done around the iron because the iron needs to be around the concrete. So now that we've looked at form work, our next step now, after the form work, is to ensure that the measure of the form work is actually correct. Now, if we look at this, the concrete is what? It's 400 mm. I like to use centimeters, so I'll just say 40 centimeter. It's 14 centimeter high, and it's about 230 centimeter wide. You can see it here. 230 centimeter wide, 400 centimeter high. Okay, we made a change to this 23, it's not 23 centimeter. Now it's about 17.5. That was a later change. We already started casting, but they gave us a change which makes it 70. So actually now the width of this concrete is 17.5. Your form work has to respect that. If you take your tape and you're measuring the form work from board to board, it has to be 17.5 on the dot. And if you're measuring the height of the form work, the carpenter will call the wood, it has to be 40. So this actually ensures that the concrete meets our height and width specification based on the plan. Now that we've done the iron, the drilling, right? Remember the drilling. Remember I said the door's job is to hold the beam to the slab so it doesn't fall off, right? Then the job of the distribution bars, these ones that go across, is to ensure that when the concrete is shrinking, it doesn't crack. That's the job of distribution bars. And we look at the form work. So iron work is done first, followed by form work. And the form work have met our dimensions, right? For in terms of width and in terms of height. Okay. Now, usually there's a wall here. And there's another wall at this point. Okay. There's another wall at this point. If you look at the drawing, let's just say that we are doing it for. Let's just say we're doing it for this place. Okay. This we're doing it for this place. So this is a wall here. So you can see that right here is a wall, and right here there's a wall. Okay, so those are the walls. Those are the walls that are guiding me. Now, after doing that, the third thing we need to do is, let me see if there's something that we've not covered. So we looked at 75 drill, we looked at T10 for the doors, also T10 too for distribution bars. We looked at the height. We've looked at what else also? We've looked at the width. Okay. All right. So now the next thing is what? To pour the concrete. Okay. You know that concrete is a mixture of what? Sand. You can add stone dust. Then you have cement. Then you have gravel or chippings. Okay. So gravel, cement for bonding, gravel for what? Occupying the volume, for the weight. Then you have sand. Then you can add stone dust. Some people don't add stone, depending on the grade of concrete you want to do. But we are mixing stone dust and what? Sand with gravel and cement. That's how we're doing it. So once you have your mix, once you have our mix, right? Then the laborers help us bring the mix. They have buckets that they carry. there's also a machine that does the mixing, concrete mixer, right? They climb the staircase, then they pour the mix into the formwork. This formwork is solid, it's very strong. They pour the mix into the form, and they keep doing that until what? I'm thinking I should use another color. I'll use another color to represent the concrete. Let me use green. So they start pouring the concrete in. The concrete is being poured in, and little by little, the formwork is getting filled with concrete. All right. Now, when the concrete reaches a certain point, okay, we insert polystyrene. Then you can see here, right? Remember, the purpose of this upstand beam is to hold glass, okay, and that glass has to be inserted into the concrete beams. In order for us to do that, the concrete beams have to have a groove. It has to have a hole, a groove. This is what this groove is, and you can see that this groove is what? 23. It's 230 mm, but it's actually 23. No, sorry. This is the width of the groove. The width of the groove is 2.5 centimeter, and the height of the groove is 120. I would just say 12 centimeter. I like to follow my tape, so I don't have to do any conversion. What I see on my tape is what I just put there when I'm measuring. So I like to go with centimeter. Okay, the difference is just remove 10. So 12 centimeter should be the depth of the groove, and of course the width of the groove should be what? 2.5 centimeter. Okay, so enough for us to form this groove. We cannot use our hand. Sure, we're going to use something called polystyrene sheet. If you've seen polystyrene sheet before, it looks like if you've bought any machine in carton, there's this white thing that you can scratch. This white thing that comes, they use it to cushion. They use to cushion the sides of the device, right, so that it doesn't break. They use to kind of like protect it. So that white polystyrene now is given to us in this shape here. Okay. Then what we do is we measure 12 and we cut it. We measure on that 12, we cut it. We measure on that 12 again, we cut it. We measure on that 12 again and again, we cut it, right? Then we attach them together based on the length of the length of the beam. All right, we attach them together based on the length of the beam. And what we do with this polystyrene sheet is that now that we've casted, we've put the concrete up to a level, we will now place the polystyrene sheet. We'll place the polystyrene sheet into, let's even say this is the level of concrete here. The concrete have come to this level. Now remember, we're watching for what? The depth of the groove, 12, right? Okay, 12 from the top. So from the top, it should be about what? 12 centimeter deep. So we place the polystyrene sheet here. On top, what we've casted, we've poured some concrete. We'll place the polystyrene sheet. Okay. Sometimes they're not long enough, so we usually use nails. We'll put another one again. We'll put it side by side. We'll attach it. Hold it with nails. We'll put another one. Okay. This joint is all off. Then we'll put another one again. Put another polystyrene sheet again. Okay. So let me just clear all these things up. So this is a little bit better. So we place the polystyrene sheet and we do that from end to end, from wall. Remember I said that there's another wall in this place. Okay, so we put the polystyrene sheet from wall to wall at that height. Then once we've placed it carefully, then at the sides of the polystyrene, remember this polystyrene is perfectly in the middle. You can see it here. That is perfectly in the middle. Okay, so we put it in the perfect middle. We just check the middle of 17.5. All right, and the weight of the polystyrene. So we put it in the perfect middle. And once we do that, then we continue pouring our concrete till our concrete reaches the top. Till our concrete reaches the top of this formwork. Remember, the formwork is 40. Our concrete is 40. The formwork is 17.5 centimeter wide. Our concrete is going to take the same shape, take the same dimension. And remember, this polystyrene is going to protrude out just a little bit. The polystyrene is going to flush with the top of the concrete. Okay, because it is from the top and it goes down about what? 12 centimeters. So at least we'll still see the top of the polystyrene. But on the side, so it's going to look something like this. If you're looking at the top view of it, you see this, you see this. You see the polystyrene sheet in the middle. Okay. At this point, the iron has already been submerged with the concrete. You will now have what? The concrete on the side like this. Okay, to now be flat on the top. Okay, so in that way now, once the concrete is dry, the last thing we do now, we wait. After we've poured the concrete everywhere, we'll now wait. Once the concrete is dry, then we're now going to remove what? We're going to remove the polystyrene sheet. So we're going to have on the right side concrete, on the left side concrete, and some centimeter deep, this middle, there will not be any concrete here. But from 12 centimeter and below, of course, there will be some concrete. So it is the middle of this that we're going to slide our glass in, that's going to hold our glass. This glass over here. This glass over here. So basically, that is how we're going to cast the upstand beam.